Find the values of a and b. If we recognize over here that finding a and b is really just finding two missing numbers, we know for a fact what do we have? What must we have already present to work out two missing numbers? We need two simultaneous equations, don't we? True or false? Is that a rule? Two missing numbers means you need two equations to work it out. Does that make sense? Yeah, I'm just explaining to you in real time the logic process, like how you would look at this question and know sort of what you're looking for in the first place. You're looking for two equations that involve a and b. And then obviously the two equations that involve a and b come from reverse engineering this. Just taking what they give to you over here and being able to write some sort of something equals to something involving the letters a and b. Starting off with this. If it's telling you it intersects the x and y axis at the points a and b, they're not telling you to find a and b, but does it make perfect sense to you why you would want to find a and b? Because it's kind of how you begin the logic here, isn't it? Like start putting the question together. Any confusion as to why you would look for a and b now? Just try to find the actual coordinates for a and b. Any confusion there, or does that make sense? Yeah? So if you know it makes sense to find the points a and b, you'd realize x-axis intersection just means, well, x-intercept. X-intercept, it doesn't apply, like it doesn't matter which equation you're dealing with, doesn't matter what it's written, x-intercept intersecting the x-axis is always going to be when the y-axis is equal to 0. When y is equal to 0, that's how you're going to find the x-axis, the x-intercept. Which means, that's how we find it over here. When y is equal to 0, we found that x is equal to a. And if y is equal to 0 over here, x is equal to a, isn't that an example of a coordinate? Because every single coordinate is x comma y. Think about the basic example. If x is equal to 2, y is equal to 6. Doesn't that just mean you have a coordinate that's 2 comma 6? So in that same way, if y is equal to 0, going to create x equals to a. Check this out. This is the equation you have. This is just there to throw you off. It's unintentionally complex to look at. Like, you might be looking at this and just think, like, this looks fucked, doesn't it? Just be honest. That's kind of your reaction when you see this, isn't it? Yeah? But you must realize at the end of the day, this is just an equation. It works the same way as any other equation. It's just there so that if you have x equal to something, you're allowed to work out what y is equal to. That's what we've done over here. We're trying to find the x-axis where it touches, where it intersects the x-axis for point A. So we make y is equal to 0. If we make y is equal to 0, the whole point of this equation is just, it's just there to be used to find what x is equal to if y is equal to 0. It's like this, isn't it? 0 divided by b, well, it's just 0. 0 divided by anything is just 0. So in the math context, it's just x over a is equal to 1. So that means x is equal to a times 1, isn't it? So far so good. That's how we got this set of coordinates. When x is equal to a, y is equal to 0. So we found point A. Same principle over here for point B. If you're trying to find the y-axis intersect, y-intercept is just what? It's always when the x value is 0, isn't it? That's the relationship you need to keep in mind, right? They're testing you on, hey, do you know that the y-intercept is always when x is equal to 0? If x is equal to 0, and you have the equation that represents the graph, it just means replace x with 0, what do you get? Y over b is equal to 1, so y must be equal to b. See what we did over here? That's how we use the equation here, isn't it? This equation allowed you to work out that when x is 0, y has to be b, which is where we found the y-axis intercept. We've got a and b now. So far so good? If you're trying to find the midpoint of AB lies on, like my point is this, okay, check this out. So we've got AB now. It doesn't really help because remember at the end of the day, we just need to find, if we want to find A and B, we need two equations. We don't have any equations yet, but we've at least got something to work with now. Okay, we've got point A and point B. What do they tell us? The midpoint of AB lies on this line. How about let's find the midpoint of AB then? Midpoint of AB, even though these aren't actual numbers, they work the same way, meaning midpoint is still going to be these x values added together divided by 2, or y values added together divided by 2. A plus 0 divided by 2, A over 2. You're not confused by why this is best represented using this, no problem. And if they're saying the midpoint follows this line, remember the relationship over here? If this is the line, isn't that the same thing as telling you y is equal to negative 2x plus 10? Why do we do that? First off, this just looks fucked up for a straight line format, doesn't it? It's always more preferable to write it as y is equal to something x, like this. So this is where your first instinct kicks in. The moment you spot this, you know it's better represented using this. And then you'd realize, yes, if they're telling the midpoint of AB lies on this line, it means it follows this relationship. Remember, every single line is just telling you a relationship. It's telling you if it's on that line, if it's on the line over here, yes or no? The midpoint is on this line, isn't it? And if the line is negative 2x plus 10, what are they asking us to do with this information? They're basically telling us, if it's on this line, which it is, it means if x is equal to something, y has to be equal to negative 2 times that plus 10. So if we're saying that x is equal to this, y has to be equal to what? Negative 2 times this plus 10. Do you see what we did over here? We changed the equation into y is equal to, so it's more easy to interpret. But what it really means is, because this point is on this line, it just means when y is equal to negative 2x plus 10, x is equal to a over 2 right now. Y has to be the same thing as negative 2 times this plus 10. See what we did? y has to be equal to negative 2 times this plus 10. See what we did over here? The y value over here has to be equal to negative 2 times x plus 10 plus 10. Do you see where we got our first equation from? It's quite literally substituting using this point into this relationship, because that's what it means for the midpoint to be lying on this line. Take a second to process if you need to. It's very important over here. You must perfectly understand how this leads to this equation. Yes or no? Take your time. Any questions? Now, once you see this, you wouldn't need to be told to simplify that, wouldn't you? There's obviously a much superior way to write that. There's a much simpler way, which is if you've got negative 2 times this, why don't you just do negative 2 times this first? Negative 2 multiplied by a over 2 just means what? It cancels out the 2's. It just becomes a negative a, right? I'm sure you understand how this algebraically becomes negative a. It's still plus 10. It's still b over 2, and then you can move the 2 over there to get b is equal to negative 2 plus 20. Remember the rule for simultaneous equations? It's always useful to label whichever equations you have so it's easier to assemble later. Next point. We've already got everything we needed out of here now. Distance AB is equal to 10. Well, we've got A, we've got B. There is a distance formula to make it equal to 10, isn't it? What's the distance formula? It's always going to be difference in x values squared plus the difference in y values. Pythagoras. Square roots of the difference in x values squared plus the difference in y values squared. So it's going to be square roots of a minus 0 squared, which is a squared, 0 minus b squared, negative b squared, which is b squared. See what we did over here? A squared plus b squared is equal to 10. And we don't need to be told this gives us this now, doesn't it? A squared plus b squared equals to 100. We've got our first equation over here. We've got the second equation now. I think you know what to do now. If you replace the b with this, you end up with a simultaneous equation that guaranteed can be solved. So that's what we did over here. We replaced the b with this equation, and you can tell it gives us one type of letter now. And without further ado, just make sure you know how to do the algebra over here. Might be a little bit tedious, but it makes perfect sense. You know how this exactly becomes. Negative 2 times negative 2a. Negative 2a times negative 2a. 4a squared, negative 2a times 20, minus 40. Two of those gives you minus 80a plus 20 times 20, 400. So you're not confused about how this line of working becomes this. You know this becomes 5a squared, which is what we have over here. Move this stuff aside, we get a quadratic. You can tell obviously they have 5 in common, so divide everything by 5. Do the same to right hand side, doesn't change it because right hand side is still 0 over there. 5 minus 16, 60. Use a calculator, you'll get a is equal to 10, a is equal to 6, which means factorization must be a minus 10, I minus 6. You know why we do the factorization? Because we want to show some working, right? This is the bullshit method, but it definitely works. And now, if you have a is equal to 10, that means what? You know a is equal to 10 or 6. Don't worry about why we cancelled out just yet. It's just right now, so far, when you look at this question, you should have a is equal to 10 or 6. If a is equal to 10, doesn't that mean b is equal to negative 2 times 10 plus 20, which is 0? If a is equal to 6, it means negative 2 times 6 plus 20, which is 8. Why did we cross these ones out? You get that these are just groups of answers, isn't it? A is equal to this, b equals this. A equals this means b must be equal to this. So far so good? You get how these groups exist. Why do we cancel these ones out? Because look at this question, a and b are positive constants. Yes or no, is b a positive constant? Is 0 a positive number? No, it's not. That's why we cancel these out. And that's why we just have a is equal to 6, b equals to 8.